Ask a physicist what happened before the Big Bang and watch what happens to their face. It is not the face of someone who knows the answer and is about to explain it. It is the face of someone confronting a question that may not be answerable at all. Not because we lack the data, but because the question itself may contain a flaw that makes it unanswerable in principle. The Big Bang happened approximately 13.8 billion years ago. In that moment, everything we can observe began. Space began. Time began. Matter and energy and the laws of physics that govern them all emerged from a state of almost unimaginable density and temperature. The universe went from something we cannot describe to something we can in a fraction of a second, and it has been expanding and cooling ever since. But before that moment, what was there? The honest answer is that our best theories break down at the Big Bang. General relativity, which is our best description of how gravity and space-time work, produces what is called a singularity at the moment of the Big Bang, a point where density becomes infinite and the equations stop making sense. A singularity is not a description of what was there. It is a mathematical signal that the theory has reached its limit. It is the physics equivalent of dividing by zero. The calculator does not give you the answer. It gives you an error. So we cannot currently use our best theory of gravity to say anything meaningful about the moment of the Big Bang itself, let alone what came before it. But physicists are not the kind of people who accept that answer quietly. Several serious and well-developed proposals exist for what might have been happening before the Big Bang, and they lead somewhere genuinely strange. The first and perhaps most disorienting proposal is that the question itself is confused. Physicist Stephen Hawking and mathematician James Hartle proposed what is called the no-boundary condition. Their idea is that time as we know it did not exist before the Big Bang. Just as there is no land south of the South Pole, there was no time before the beginning of time. Asking what happened before the Big Bang on this view is like asking what is south of the South Pole. It feels like a meaningful question, but it assumes something that does not exist. The question has a grammatical form that looks valid, but a logical structure that is not. On this view, the universe did not come from anywhere. It simply has a boundary in time the way a sphere has a boundary in space, but no actual edge that something exists beyond. The second proposal takes a very different direction. Cosmologist Roger Penrose at the University of Oxford has proposed what he calls conformal cyclic cosmology. His idea is that our Big Bang was not the first, that the universe goes through endless cycles. Each cycle begins with a Big Bang and ends in a state of maximum entropy where all matter has decayed and the universe is a cold, dark expanse of nothing but photons. And in that final state, Penrose argues the universe undergoes a conformal rescaling that makes it indistinguishable from a new Big Bang. Our universe is just one cycle in an infinite sequence of universes, each born from the death of the previous one. The third proposal comes from string theory and is called eternal inflation. In this model, our Big Bang was a local event within a much larger structure called the multiverse. Space outside our observable universe never stopped inflating. It continues to inflate eternally, and within that eternally inflating space, occasional quantum fluctuations trigger new Big Bangs, creating new bubble universes, each with their own physical constants and laws. On this view, before our Big Bang, there was an eternally inflating void that had always been inflating and will always continue to inflate. Our universe is a bubble that formed within it, and what we call the beginning was just the moment our bubble pinched off from the larger structure. The fourth proposal involves a collision. In the ekpyrotic model proposed by Paul Steinhardt and Neil Turok, the universe exists on a membrane floating in a higher dimensional space. Our Big Bang was caused by a collision between two such membranes. Before our Big Bang, the membranes were approaching each other through the higher dimensional space, and the collision released the energy that created our universe. On this model, there was a before. It was just a before that existed in more dimensions than we can currently perceive. Each of these proposals is serious. Each has been developed by leading physicists, and none of them can currently be tested against observational evidence in a decisive way. They are not wild speculation, but they are not confirmed science either. They exist in the space between where our knowledge ends and where our mathematics can still reach. What they share is something important. They all suggest that the question of what was before the Big Bang cannot be answered by simply looking further back in time. It requires rethinking what time is, what space is, what it means for something to begin, and whether the concept of before applies to the universe in the same way it applies to events within the universe. You are made of atoms that formed in the first minutes after the Big Bang. You are made of elements that were forged in stars that lived and died before our sun was born. You are a structure assembled from the oldest available materials in the universe. And the question of where those materials ultimately came from is a question that may require a new kind of physics to answer. Or it may be the kind of question that has no answer at all. That distinction matters, and we do not yet know which one it is.